Okay, so what we did, I showed you guys this little computer simulation, or no, I didn't show y'all that. That's okay. If you're watching this video, you didn't see it either, so that's fine. But what I did show you guys was kind of something where we would have something that looks like this, and we would want to rotate it about the x-axis. And remember how we said it kind of looks, it's kind of going to look something like this, and it's going to be completely solid. And if I were to slice this thing up, what shapes would this make? No, what would the slices?
Oh,
so this looks like a wizard's hat or a trumpet or something. The slices would be circles. So I want you to see there's no like gaps. This thing is solid through and through. It's not hollow, okay? However, if you had something like this, okay, and we were rotating it about the y-axis, okay, this would look more like a crown. It would look kind of like a glass. Think of like a real glass, made of glass that's cylindrical on the outside, but it's very beveled and curved on the inside. That's how most glasses work. Okay? This right here, if you were to just go through and slice it up, would it be solid circles? When you think about it, if you had glass and you just cut it like with a really sharp knife, it wouldn't make a solid circle. Okay, there would be a hole in the middle, and if you kind of looked at it from the top, there would be a hole in the middle. Okay, this is what we're going to call a washer. Now, you already know how to find area of a circle. That's easy. That's just pi r squared. Okay, where r is the radius. So we're going to talk about how to find the radius. Washer, though, we've got to think a little bit more outside the box. So we have a big radius, and then we've got, I'm just going to draw it over here so that's separate, we've got a small radius. So if I wanted to find area of this washer, I would do area of the big circle, and then what would I do? Minus area of the small circle. And the way we're typically going to see this is have pi pulled out to the front. And if we're going to integrate this, which we know we are with volume, going to probably integrate, this pi could even be moved in front of the integral. We're going to be doing this in our calculator, so it doesn't really matter whether you do that or not. All right? And so it's not the exact same as the cross sections, okay, but I'm still going to be using a lot of the same language as I did before. All right, so we get to this problem, and I give you these functions, and then I tell you we're going to revolve the region bounded by the graphs about the given line. Okay, and the first two have to do with the x and y axis. These are generally easier scenarios. And then these two have to do with lines that are not the x and y axis, although we're going to use the same properties on all of these. Okay, so the first thing we need to do is graph these. Remember how with cross sections we kind of got away from graphing and we could do the problem without graphing it at all? You're not going to be able to do that on these. You're going to need to graph every single time on these. And that's not me saying you have to, that's me saying you're not going to know what to do otherwise. And the reason I say that is because, okay, we start with this picture. We can go ahead and just graph the whole thing. And I'm not spending a whole lot of time on the graph because we've already spent time on that. All right? Before, when we did area, it was just area of that shape right there. And that area was the same no matter what. Whether I did this with respect to x or y, you got the same for the area. Now, when we did the cross sections, it did matter, but the base itself didn't change. The difference about this whole revolving thing is that it's going to make a different 3D shape depending on how you revolve it. So on this first one, let's revolve this about the x-axis. Okay, so what I want to show you, let me extend the x-axis a little bit. And I'm going to do this little symbol. That means I'm revolving this shape about the x-axis. So we have this, it kind of looks like a triangle, and it's hinged on the x-axis. So it's going to swing around, and it's going to make a 3D figure. All right, and so the easiest way to do this would be to first just reflect it. Anytime you want to draw a 3D picture of the revolution, first just reflect about the line that you're revolving it around. Then just add a little bit of depth to it. Okay, so what shape is it? What's something in the real world that looks
Like a top?
kind of like a top?
Or do you have
Or like
A hat, except a hat would be hollow, and this is not hollow. And it kind of looks like a bullet,
yeah.
kind of like half a football. There's lots of different things you could think, but the main thing I want you to get across is this is solid. Because this shape originally was solid, it's going to go all the way through. So you might be having questions, well, how do you know it's not solid? Well, we'll get to that here in a minute. But in order to find the volume of this, we've got to first determine whether this is respect to x or y. Now remember when I told you perpendicular to the x-axis was with respect to x?
Yeah.
Well, revolving about the x-axis is also with respect to x. So that's kind of nice that it works out that way. All right, if you can determine that this thing is solid through and through, we're going to say that we're going to write this word circle, and we're going to use the equation of a circle. So this is what I mean. If I were to take a big knife, a really sharp knife, and slice this thing, it would not be something with a hole in the middle. It would be a solid circle through and through. So I don't have more than one radius, basically. This is the easier scenario. So remember that area of a circle is pi r squared. So the volume of this thing with respect to x would be left to right. That's just like how we did it before. And we're going to write pi r squared. And then with respect to x means dx. All right, we've actually done most of the work at this point in the problem. We know, hopefully, if we do a good graph, what the left and right is. What are these x values? 0 to 4. If we were doing this with respect to y, well, the picture would look totally different, so I'm not going to go there. All right, this pi at any point could be moved to the front. All right, I'm not moving it right now, but I just as easily could have. I don't know what r is, okay? So what we got to consider is back to our original picture. Okay, this was my original picture. R is going to be the radius. I mean, if you think about this, R is the radius of any of these like ninja chop circles. Okay, so this right here is R. It's kind of like half the slice again, but I really want you to get a handle on the picture of what's happening here. Now, is the radius, like if I were to chop this towards the left and then I were to chop it towards the right, would the radius be the same?
No.
No. When would the radius be the same? What type of shape would I need? A cylinder. Like the 3D figure, I would need a cylinder. And then you chop it and the radius would be the same no matter where you chop it. But because this kind of goes down towards one end, the radius changes. It depends on x. So I have to do the whole top minus bottom thing. Okay? So with respect to x, what's the top function?
The
Square root of x. And with respect to x, what's the bottom function?
0.
0. So the whole top minus bottom, and on another problem we may do right minus left, that part's not changing. There's a lot that carries over, and I want you to really focus on that. I don't want you to think how different this is. And so we don't really need the minus 0 part, right? And the nice thing about the axis is it's always 0, that second part. So we're going to have square root of x squared right there. And then dx. Now, do you think you could do this one by hand?
Yeah.
Yeah, pull the pi out, square root of x squared is just x. Could you integrate x?
Yeah.
And then plug in your numbers? Of course you could. All right, so we're just not really going to spend too much time on this. But the answer here is 8 pi. We've spent a lot of time in class typing this in. I will tell you on your test, for me and on the AP test, a lot of times they tell you just to write the integral but do not evaluate. And that is to save you time, or maybe it's because it's on the non-calculator part or whatever. Okay, so my test will be all calculator. All right, but sometimes you're not even going to have to do the whole thing. Because it does get tricky typing it in your calculator, especially with parentheses. And this is a simple one. Some of them are going to be more complicated than this. All right, so let's look at the next one. So if I were to revolve my original picture around the y-axis, I can't even really look at this picture. Okay, it's going to make a completely different shape. So you're going to have to start with a completely new graph. And this is the part where my other students were like, do we have to? The answer is yes, you do. Not because I'm just trying to be mean, but because I want you to be successful at this. If you don't draw a new picture, you're going to get stuck. Okay, so this was my original square root of x, and then it was shaded like right there. Okay, here's y-axis, here's x-axis. So on this problem, since I'm rotating about the y-axis, do you remember how I told you, how do you draw the rotation?
It's reflection.
You draw the reflection, and then you just make it 3D. And don't worry too much about, is this curved enough? The picture is there to help you. And then the base here, would look circular. Okay, so the hardest part here is trying to think, okay, what does this look like in real life? So can anybody, some people have a real knack for this. Anybody think they know what this looks like? Maybe from the outside, what shape does this look like?
To me, it looks like it's like a circle that has like an indent in the middle, kind of like a lightsaber or like a hard candy. It's like
Yeah.
indented.
I see what you're saying. So the bottom of this is a circle, okay? The sides are straight up. So tell me, what shape has a circular base and the sides are straight up? What's the geometric term for this shape? A cylinder. So from the outside, it looks just like a cylinder. So we'll say a cake, because I'm going to tell you what we're going to do next. The only thing is, instead of the top being level, like how a cake should be, it's completely caved in. So have you ever baked a cake and the middle of the cake fell in? Anybody? That happened to anybody? It's happened to me. If you haven't baked cakes, it's hard to get a cake not to fall. Okay, you have to make sure. Or let's say you baked the cake and it was great, and a little toddler came in and just punched their hand down the middle. That's what this shape looks like. So what I want to ask you first of all is this problem, can we say, look at the rotation here. Do you think this is still with respect to x? No, it's with respect to y, which hopefully makes sense. Revolve around the x-axis with respect to x. Revolve around the y-axis with respect to y. All right, now when determining whether this is a circle or not, we're thinking about our slices, and in this case our slices are horizontal. All right, if I were to take a knife and just slice through this cake, would every slice be a circle or a washer? It would be a washer, because there's a big hole in the middle. You see that? The 3D figure has a hole in the middle. The very bottom may be a pure circle, but even the top would just be like a ring, okay? And so that's how you know you have a washer. If you think it's a washer, it probably is. If you have any reason to think there's a gap in the graph, I'm sure there is. So let's go ahead and write this, go ahead and set it up. So first of all, with our volume, we're going to do bottom to top. Okay, that's just the same as how we did before with volume, with respect to y. And then, instead of pi, just little r squared, we have our new formula that I wrote at the top. And then that's going to be dy. Okay, so you're probably going to figure this out, but really, besides the setup, the hardest part here is knowing what your r is. And in this case, I have two different r's. Okay, so let me show you how you want to do this. You want to start with whatever you're revolving around. You want to take that to the outer rim. It's hard to draw straight lines with this tool. There we go. You want to go all the way to the outer rim. And you want to think, because it's possible it's not changing. So you want to think, is this big R changing or not? And notice that I'm using my original graph. I'm not going to use that part of the graph over there, because I don't know these equations. So, in other words, thinking back to the cake, from the very center of the cake to the very outer rim of the cake, is that changing?
No.
No. What is it? It's a constant, and what is that constant?
2 or 4, sorry.
It's 4. Here's another way to think about it. Let's say you didn't realize that, and you thought you just wanted to just go through the steps. What's the right function over here? X equals 4. What's the inside function right here? X equals 0. 4 minus 0, that would be 4. So you're still doing the whole top minus bottom or right minus left. Every single time you find R, that's what you're doing. Okay, now for the little r, what you're doing, and it's kind of hard, I really probably should change colors here. Here we go, red. What you want to do is from your axis of revolution to the inner part. Now, I drew mine right here, down at the very bottom, where r is tiny. What would have happened if I drew little r closer to the top? It would be bigger. So r, little r, is depending upon x. So again, though, we're just going to do right minus left. Okay, now this is the graph of y equals the square root of x. But if I'm talking about with respect to y, and this is something you're going to, anytime we have lots of parts, this may be something you want to do at the beginning, I have to know what is this in terms of y. So I have to go through and actually solve for x right here, but typically this is pretty easy to do. So what does x equal? Y squared. Okay, so that curve right there, that right, is y squared. And the inside again is 0. With the axis, you're always going to have this minus 0 thing pop up. All right, but I'm going through the steps so that when I get to these harder ones, it'll make more sense. Okay, so little r, which depends on y, is y squared. Big R, big radius, is 4. So if I were to slice this cake sideways, slice, 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 the outer rim would be the same radius no matter what. The inner rim, depending on where you made the slice, could be really small, could be really big. Okay, so now what I need to do is go ahead and put it all into the formula. Okay, so I need to do bottom to top, 0 to 2, pi, okay, big R squared, which is 4 squared, and I need to erase just a little bit of this. You don't need it anymore anyway. 4 squared minus little r squared. Now r itself is y squared, so I need to square that. dy. There can be a lot of parentheses going on here. That can happen. So you got to be careful with that. And like I said, though, you're not even always going to have to solve it out. All right. This is 128 pi over 5. If you feel like your calculator skills are good, I wouldn't worry too much about this. If you know you're the type of person that's always getting calculator stuff wrong, you may want to go back later and try some of these and make sure you're getting the same answer. Okay, so now we get to this one, the line x equals 4. So we start with a graph. We cannot just use the same graph. All right, we're going to start with the basic same shape, but we're going to go ahead and let me go ahead and do this graph over here. Just because I really didn't leave myself enough space. The nice thing is you do, at this point, you should know what the basic shape is. Okay, so that's the basic shape. We're going to revolve this thing about the line x equals 4. What type of line is x equals 4?
Vertical.
It's a vertical line. Now the nice thing about this one is it borders our shaded region. So what do you do when it doesn't border? We'll get to that in part D. Alright, so this right here is the line we're revolving about. So let me label my axes here just to make sure that it's clear. This right here where the little revolving sign is, that's the line that we're revolving the shape about. So we need to determine two things. First of all, what are we with respect to? And is it a circle or a washer? So let me ask you, does this revolving look more like A or B?
B.
What does everybody else think? Revolving about a vertical line, does it look like A, where we revolved about the x-axis, or B, where we revolved about the y-axis? It looks like B. So when you have this x equals 4, you might think, oh, that means with respect to x, but it actually doesn't. Now, however you have to remember this, do that. I think probably what's best is just stick with the x and y axis, and when you get to these lines, think, is it like the x-axis or is it like the y-axis? And then you don't really have to memorize anything. All right, now in order to know whether this is a circle or washer, some of you already know what this shape looks like. A lot of you need to kind of go ahead and visualize it. Now again, our revolving line was right up next to this shape. So do you think this is a circle or washer?
Circle.
It's a circle, good. If that line had been like a gap, we would have had a washer, and we'll see that in part B. All right, that's really the only reason you have to graph this piece over here. So like once you've done that, if you want to erase it, you could, because we're definitely not going to use this to determine R, because I don't know what that equation is. I'm going to have to like do a lot of algebra to figure out what that square root looks like over there. So we definitely don't want to use that. But that's up to you, whether you want to erase it or just know you don't need it or visualize it in your head. You do want to show this graph. This is the kind of thing that gets you partial credit when you're not sure what to do. All right, these two pieces of information here tell us how to set up the problem. So with respect to y means we do bottom to top integration. The circle part means we just do pi little r squared. And again, with respect to y means dy. You've gotten half the points if you can get this far. The other half are going to come from knowing what, maybe not quite half, but almost. The other points are going to come from knowing what little r is. So again, start with your line of revolution, and with little r, it's just nothing, there's no like, is it outer, is it inner? You just draw the slice, basically, kind of like what we call it before. So what would R be if we do right minus left, which is what we have to do here? Okay, I'm going to write it up here. R is the right in terms of y, x equals, that's 4. This is where it gets a little bit more complicated. We don't get that minus 0 aspect. We have 4. And then what is this curve with respect to y? Do I put square root of x or do I put y squared? You have to do y squared because it's, when you're doing your r with respect to y, you have to do right minus left is x equals what minus x equals what. This is going to take practice. This is why you have tomorrow to work. You're going to have some Monday to review and all that kind of good stuff. Okay, so bottom to top. 0 to 2. Once you get that, you should just be breathing a deep sigh of relief because the rest is just plugging in. So 0 to 2, we have our pi. Again, the pi could definitely go to the front. Our r is 4 minus y squared. Don't forget to square that. And then dy. And you're just, at this point, you're just typing this into your calculator. Okay, you get 256 pi over 15. I know I'm going through that part fast, but I really want to make up for lost time yesterday. Okay, I know this is confusing, but it should be, like with each one we do, more questions should be answered, but feel free to ask questions if you have them. Okay, let's look at D. All right, so again, we have to redraw the graph. I'm not saying there's a point when you won't have to graph. You might get to a point where you don't have to graph anymore, but that point is not today, and it's not tomorrow. It's probably not next week. It's way too hard to visualize, I think, what this is. And it doesn't take that long to just graph this. In this case, we're revolving about the line x equals 6. Again, we have another vertical line, but here, x equals 4, we have to go 2 over, and this is the line we're revolving about. So my other shape is over here. Okay, this is just to help us see what type of, whether we're going to have a circle or a washer. That's the big deal about this, about reflecting it and knowing. There should be an extra tick mark there. Okay, so first of all, I can see that C and D are awful lot alike, so hopefully we know that this is with respect to Y. Circle or washer? Has to be a washer. If our thing on C was like a cookie, D is like a cookie with the middle cut out, like almost like a donut. That's what this is happening. It's still going to be solid on the outside. If there's a hole in the middle, that makes a washer. If there's any gaps, you're probably going to have a washer. I mean, you are, but if you can interpret any gaps, it's a washer. So my volume then is going to be, again, with respect to Y, is bottom to top, pi, and hopefully you start to see that this is really just one big puzzle, and you're kind of doing the same thing each time. It's not magic, it's not mystery. It is hard to visualize, but even if you can't visualize the problem, that's okay. You don't even have to look at the 3D picture. Look at the 2D picture. The thing you got to remember though is start from your axis of revolution. Okay? If you go to the outer rim, that's your big R. If you go to the inner rim, that's your little r. So I want you on your own paper to go ahead and write down what you think big R and little r are. And if you're feeling pretty confident, go ahead and plug it into the integral, and if you have your calculator, go ahead and type it in. If you're stuck on big R, go to little r. It's easier. Okay. Anybody think they know what big R is?
6.
6 minus y squared. Very good. You have to start with the line of revolution. That's your right. And then your left, since we're with respect to y, we have to use y squared. if you said 6 minus square root of x, you were just not staying true to the whole with respect to y thing. What about little r? 2, this one's easier. Because you could do 6 minus 4, or you could just say, you know what, that's not changing, it has to be 2. And so then we plug it in, again 0 to 2 just like the last one. Big R, you do need to be careful about parentheses here, especially if you're going to type this in your calculator. But again, on the test, a lot of these you're not even going to have to type in. This integral, typing at this point, the answer after, if you did all this right, and then your answer was wrong, you would miss 1 point. Okay, because the parentheses can be, it can take a lot of time and easy to make mistakes, I guess. So this should be 192 pi over 5. Really would encourage you though, if your parentheses on the calculator, if those get you, you need to practice this. And some of those still are points. Alright, let's turn the paper and we're going to kind of skip around so that I can make sure we get to one of each type. Let's actually do 3 next and then we'll see how much time we have left. This 3 makes an interesting shape. So what shape did these 2 functions make?
Parabolas.
They're both parabolas. All right, and so let's graph it. Y equals x squared, and you can graph it in your calculator if you want, and then just sketch that right here. That's fine too. All right. However you do it, you just gotta do it. I don't know what else to say about that. It's not that hard, though, to sketch a graph of y equals x squared. You should be really good at this. I'm going to actually sketch the other graph in another color, just to show it. Because since they're both parabolas, I'm going to have to make sure I know which parabola is which. So if I just started plugging in numbers, which is how I think a lot of you would do this, if I plugged in 0, I would get 0. If I plugged in 1, I would get 3. If I plugged in 2, 4 times 2 is 8, minus 2 squared, so that would be 4. And there's my point of intersection. If I plugged in 3, I'd get another 3. And I have the advantage because I've already worked through this problem several times. But the whole thing is, you've got to be able to find your bounded region, right? You've got to be able to find that. The rest of the parabola doesn't mean anything. Okay, so it kind of looks like a flower petal or a really elongated football or something like this right now. Everybody with me? All right. X-axis. We're rotating about the x-axis. We just draw a little reflection. Again, I'm not even going to draw it completely accurate because I just want to have an idea. What shape is this going to make? Like what 3D shape? Or what's something it would seem like in real life?
Kind of like a bowl, but like in.
Kind of like a bowl.
It's like
You have this thing and it goes all the way around. So it's a bowl. And the outside of that bowl is curved exactly like how you think it would. And it's on its side, by the way, for everybody else who's like, I don't see a bowl. It's on its side. But the inside, instead of being curved the way you think it would be curved, it's like curved the opposite way. All right, so it's not really exactly anything that we know. But here's what we do know. If we rotate about the x-axis, that is with respect to x. We do know that, regardless of the picture. Is there even a hint that there's a hole in this graph? Yes, so that means we're not dealing with the circle, we're dealing with the washer. So I can go ahead and set up my problem. With respect to x would be left to right, pi, Washer would be big R squared minus little r squared dx. You've gotten some points here, some good points, without doing a whole lot of calculus, really. All right, you are going to have to be able to figure out, okay, well, what's big R and what's little r? And if this reflection piece is throwing you off, just erase it. Because I don't know what those equations are, so I don't want to use them. I want to use that original part of my graph. Okay, so let's think about this. Big R, all right, start at your axis of rotation and go all the way to the outer rim. That's your big R. Let's see, where am I going to write this? Over here. So I would do the top, which is, if you color code it, it's really easy to tell, but if not, you just say, where's the negative x squared, the upside down parabola. So that would be 4x minus x squared, and then the bottom would be 0. And again, when you're rotating around an axis, that's going to happen. It's going to be something minus 0 or 0 minus something. Okay? Well, we're not going to get into that. These can, I will tell you, these can get even harder than what we're doing, but this is what you can expect, and that's why you're not in BC. All right? Okay, so little r. Okay, little r, that's going to be right here. That's going to be from my line of rotation, but to the inner rim, which is also changing. So which parabola is this? X squared. And again, you can write minus 0, but you don't have to. So what I really want to bring home here is that to find big R, little r on any problem, all you're doing is top minus bottom or right minus left. And the way you know which one is by clearly distinguishing whether you're with respect to x or y. And you do that by what's given. So we just plug everything in. If you graph this really nice and neat and you figured out that they have a point of intersection right here, you would get 2. Can anybody give me a way maybe we could find these bounds another way, if you weren't sure? How did we find the bounds before? Set the two functions equal to each other. That's a really nice tool that we can use. Now, if there's more than 2 points of intersection, then you could have a problem, but this is something that you can always use. It's the same as before. So big R, I'm going to put in parentheses 4x minus x squared. Got to make sure that thing's squared. Big R squared minus little r, which is x squared, squared dx. This is a perfect example of one that you would really not be asked to go any further on this one, most likely. I keep putting it in the whole most likely thing because I never know what they're going to put on the interview test. All right, but I just cannot see them wanting you to calculate this. This could take a while. I am going to go ahead and give you the answer so that you do have all of these. But this is 32 pi over 3. Okay, so then let's go ahead and do the y over 6 one. Can you use this exact same graph? I don't think you should. I think you should draw a new graph because it's revolving around something else, and we're not going to do 4, so I'm just going to scratch that out, and I'm going to do the graph down here. So here's our little shape. This was at the point 2, 4. And if I'm revolving about the line y equals 6, well, here was y equals 4. Fill that in. 5, 6. This is my line of rotation right there. X-axis, y-axis. So this is even weirder. Okay, but we only really put that there so that we can determine whether it's a circle or a washer. You probably could have figured out as soon as these two weren't connected that we have which one?
Washer.
A washer. With respect to x or y?
X.
So is this revolution around a horizontal line, is that like x-axis or y-axis? It's like x-axis, so it's with respect to x. That's what I would just encourage you to do when you get to these lines that aren't axes. All right, this is definitely a washer. Okay, so going back to, we need to know what big R and little r. Okay, start at the axis of revolution. Go to the outer rim. You got to think, with respect to x, what are these two functions? The top one, what's that? Y equals 6. I know I'm losing y'all. Y'all are tired. Hang with me here for just a couple more minutes. 6 minus this one was the facing up parabola, which is x squared. Okay, let me do this one in green. Little r is just from your axis of revolution to the inside part, the inner rim of this, whatever shape this is. It's like that weird bowl, but like with the bottom punched out. All right, so that would still be 6. That's still the top. Let me fix that. It'd be 6 minus, what would the top function be?
4x.
Yeah, and since it's after a minus, you've got to put that in parentheses or distribute. So when you're writing your answer, I would suggest you start with the whole left to right, pi. You know, we didn't write this before because I like seeing that. We only have a little bit of time left, but. And then the left to right on this one, just like the other one, was 0 to 2. Then here's where the parentheses just go off the charts. I need more room. It's worth it. Because I'm going to write this a little bit bigger. So this volume is 0 to pi. And again, the pi could easily go out to the front. It doesn't really matter. Okay, 6 minus x squared. That's my big R. That needs to be squared. Minus my little r is 6 minus 4x minus x squared in parentheses squared. Okay, yeah, there's a lot of parentheses there. So again, this is not one that I would have you compute. This is one where it would either be multiple choice, where your answer choices would look like this. Maybe the whole minus here. You've got. All right. The answer to this one is 64 pi over 3. You do have homework. It's out of the book. If you care to know, you can stay here for just a second while I find it. If you are in a hurry and you just want to do it tomorrow, that's fine too. Okay, so here is the homework assignment for tonight.
4:30 in the morning.
I can't win. There we go. Those 4 problems.
Yeah, there's that. That's shorter.